Welcome to the data analysis lecture of our second project. We are going to start by importing our libraries, import pandas as PD and import Seaborn as SNS. After importing the libraries, let's add cells. We are going to define df and pd.readCSV. Here's our data, car data.csv. Let's check the first 5 entries. We have the columns of user ID, gender, age, annual salary, and purchased info. 1 if it's purchased, 0 if it's not. Let's check data frame.shape. We have 1000 rows. Data frame.info for general information. Data frame.duplicated.sum. Let's see if there is any duplicated value. No, there isn't. We got the value of 0 and check for the NA values. We don't have any NA valued rows, so we can drop the user ID column that we are not going to use any of our predictions. We can see it's dropped. Let's get the numerical summaries for our data. The average age is 40, average annual salary is 70,000, and purchasement ratio is 40%. We have 516 female and 484 male in our dataset. Value counts for the purchased column. 402 customers bought the car. Let's make our data visual by sns.hisplot. X is equal to the annual salary. There's a typo on annual salary. Let me fix it real quick. We need to add underscore into it. As we can see, the female customers earning more than the male ones in our dataset. sns.hisplot x is equal to the age, data is equal to data frame df, let me correct the typo, and we can see that female customers are older in general. As expected, who earns more is likely to buy. Let's create another his plot. From Seaborn, x is equal to the age, data is equal to the data frame, df. And hue is equal to the purchased. Let me correct the typo real quick. And the older customers is more likely to purchase the cars. df dot correlation purchased column dot sort values, and we can see age is more related with purchasement information. Welcome to the feature engineering lecture of our second project. Let's get the dummy variables for the gender column so we can include them in our machine learning model. As you can see, we got the dummy variables and we can drop one of that columns. Let's drop the gender male column. Axis is equals to columns. Let's define our x variable and use array, age, and gender female. We can use copy or not. It's a decision. Let's define our y, df, purchased. Let's import train test split. You know that it's a really important process in any data science project because we want to test our models if they are whether good or bad. X, Y, and test size is equal to the 0.3. That means 30% of our data is going to be our test data, which is not going to be included in our machine learning models. Let's import standard scalar from sklearn.preprocessing, and scalar is equal to the standard scalar. Scaled x train is equal to the scalar fit transform. X train and scaled x test is going to be equal to the scalar dot fit transform x test. Only scaling the x variable is enough for this dataset. Let's define a function again for getting our machine learning model results for not writing after every algorithm. Predictions is going to be passed in, and we are going to be printing accuracy score in model is dot format accuracy score, y test, and predictions, which we post in. Welcome to the machine learning lecture of car purchasement data. We are going to start with logistic regression to our classifications. From sklearn.linear model, import logistic regression. Logistic model is equal to the logistic regression, and we are going to fit our model scaled X train, Y train, we are going to use values.ravel logistic model.predict scaled X test, and we can get our accuracy score from model performance logistic predictions. And our accuracy score is 0.84. Let's keep with k nearest neighbors. There's two methods for selecting the number of estimators. One is elbow method and the other is grid search. We're going to start with the elbow method. Elbow method is the manual process that we select the number of neighbors manually. We are going to create a list as test errors and write a for loop for the neighbor cons 1 and 30, KNN model, and number of estimators is equal to the k KNN model dot fed scaled X train and Y train. We're going to get the predictions for the each n value, create a variable as test error rate, which is going to be equal to the 1 minus accuracy score. And we're going to append them to the test errors list that we created in order to interpret the results. Let's import matplotlib and plt.plot range 1 to 30 test errors. And our y label is going to be equal to the error rate and X label is the number of neighbors. As you can see, the best model performance is between 10 and 15. Let's say 12 to it. And we're going to build our model with n equal to the 12. Let's fit the KNN algorithm. Scaled X train, Y train, values Ravel. We are going to store the predictions. KNN pred equals to the KNN model dot predict. Our accuracy score is 0.93 by album method. And let's try grid search for finding the best number of neighbors value. From sklearn.model selection, import grid search cross-validation CV. We are going to import also pipeline. From sklearn.pipeline, import pipeline. Let's set our pipeline KNN. Grid search parameters. Number of neighbors is going to be equal to the k values that we defined. Let's apply grid search pipe, and parameters of the grid search cross-validation is going to be equal to the 5. The scoring is going to be accuracy. And we found the parameters that we need. And let's check. We fit our values, and let's check the best number of neighbors. No, it's 30. We found 12. We didn't found. I just selected it with my eye, but it's obvious that computers choosing is better. And let's store our predictions from the number of neighbors is 13. And let's get the accuracy score from our model. We are going to pass the predictions into our model performance function, and our 0.93666. Welcome to the second lecture of machine learning in the car purchasement data. Let's import support vector machines classifier and define it. And we're going to create its parameters for grid search. C is going to be equal to the 0.01, 0.001, 0.51. Once again, grid search is the search of the combinations for finding the best parameters of the model. We use grid search for hyperparameter tuning. We are going to use linear RBF and poly for kernel. Let's apply grid search, cross-validation, our model and our parameters inside it. Let's fit scaled X train and Y train. Also, we are going to use values.ravel. Let's store our predictions in pred. We are going to predict scaled X tests. And let's get the model performance by passing predictions into our function, and our accuracy score is 0.92. Let's import decision tree classifier. Let's fit our model scaled X train and Y train. Store the predictions in tree pred. Scaled X test, we are going to predict, and let's get the model performance and see our accuracy score. It's 0.89. Lastly, we are going to use random forests. Let's import it from sklearn.ensemble, and let's define RFR model random forest classifier. We are going to define the parameters of the grid. Number of estimators 32, 64, 128 and 256. Maximum features 2, 3, 4. Bootstrap, true and false. OOB score, true and false. And we are going to define the parameters of the grid search of our random forests model. Let's define number of estimators, maximum features, bootstrap and OIV score is going to be our parameters for the grid search. And we are going to fit after finding the best parameters. It's looking for the all possible combinations and trying to find the best performing model and its parameters. That's why it takes time. Now it's fitted and the parameters are found. Let's get the best parameters and then we can build our model. Our best parameters are bootstrap true, maximum features are 3, number of estimators 32 and OOB score of true. Now I'm going to create random forests model with these parameters which we found by grid search. And we are going to fit scaled X train and Y train. Let's store the predictions. And let's get the model performance of the random forests with the hyperparameters. It's 0.87. And the best performing model was K nearest neighbors, which we found by grid search, not by album method. Thanks for contributing.